Alright, so up next we do a little bit of exploration with the closure property and just kind of walking through how these things work. So the first thing that the instructions tell us to do is complete each equation below. So I'm going to go ahead and complete those, and then we'll come back and figure out what we need to do next. So 1/5 plus 1/4, I need to put those in common denominator. So I have 4/20 and 5/20. So together I have 9/20. Then here I have the square root of 2 times the square root of 2. And so with my calculator, I'm going to check that one out. Square root of 2 times the square root of 2, and I get an answer of 2. Here I have -5 minus 7. I'm going to get -12. Then I have -3 times the square root of 36, so -3 times 6. -18. Square root of 5 minus the square root of 5 is going to be 0, anything minus itself. Here we multiply this, we get 14/36, which simplifies to 7/18. Negative square root of 16 is -4/5, -4/5. -3 squared plus 0 is going to be a -9. Okay, if this had been in parentheses, it would be a -3 times -3, but in this case it's really a negative times a 3 squared, so that's why it's going to be that -9 there. Pi divided by pi is 1. Let's rewrite this with common denominators, and we end up with 3/8. 1/2 divided by 0, anything divided by 0 is an error, so it's no solution. And then negative square root of 3 plus the square root of 3 is also going to give me 0. Okay, so what happens here as we work through these, next question said, or next part of the directions is place an equation in each box based on the classification of the terms and what you know about the closure property. So for example, this is a rational number and this is a rational number, and we're adding them together. So rational and addition. We have 1/5 plus 1/4 is equal to 9/20. Okay, then here I have two irrational numbers and multiplication. So irrational and multiplication, I have square root of 2 times the square root of 2 is equal to 2. Next I have -5 minus 7. Notice that it does say in the directions some equations could be used in multiple boxes, but you cannot use an equation twice. Okay, so we're going to be putting these in here. So these are both integers, or an integer and a rational number. So if we, yeah, they're both integers. So we're going to put this under integers and subtraction. So -5 minus 7 is equal to -12. This one up here is -3 times the square root of 36. Sorry, let me put that back up here so you can see it. We have a, let's see, integer and another integer here. So -3 times the square root of 36 is equal to -18. We have the square root of 5 minus the square root of 5, so two irrational numbers subtracted. We have two rational numbers that are being multiplied, so 7/12 times 2/3 is equal to 7/18. We have an integer and another integer being divided, so negative square root of 16 divided by 5 is equal to -4/5. -3 squared plus 9, that's going to be another addition, so -3 squared plus 0 is equal to -9. Pi divided by pi is equal to 1, so that's two irrationals and division. Then we have subtraction and two rational numbers, so 7/8 minus 1/2 is equal to 3/8. And then these are both, rational numbers, so 1/2 is a rational number and 0. Even though 0 falls into another category as well, the category that both of these do fall into is rational, so we're going to put those in rational and division. Divided by 0 cannot be done. And then here we have two irrational numbers being added together, so the negative square root of 3 plus square root of 3 is equal to 0. Okay, so I've grouped these based on what type of number each of the pieces are and what property, or sorry, what operation we used on them. So now I'm going to look at the terms and the solution here and decide if they are closed or not. And so the directions tell us just to highlight the boxes that are not closed. Okay, so if I look here, I have a rational number plus a rational number, and that equals a rational number, so that is closed. So I'm just going to put a check mark up here next to that one so I can keep it in track of it. Okay, then I have, let's see, 7/8 minus 1/2, so rational number minus a rational number gave me a rational number. So that one is another example of closure. Then we have 7/12 times 2/3 is equal to 7/18. That one's an example of closure. And 1/2 divided by 0 does not give me a rational number. So that one is not. So I'm just going to highlight that square right there. Okay. All right, then I have two rational numbers give me a whole number, so that is not closure. So I'm going to highlight that one as well. Two irrational numbers also give me another whole number, and I'm just putting an X next to these because they are not representing closure. The square root of 2 times the square root of 2 gives me a natural number, so that's also not closure. Pi divided by pi is 1. That's two irrational numbers giving me, again, a natural number. Okay, then down here I have two irrational numbers, two integers that are giving me another integer. So this is an example of closure. -5 minus 7, two integers. -12 is also an integer, so that's closure. Integer times an integer, still getting an integer, closure. And then integer divided by an integer gave me a fraction, which is not an integer, so that one is not closure. Okay, so now these are not the end-all be-all, but this kind of gives you an idea of what the closure looks like. But you see kind of a pattern forming on some of these. And again, these are just one example. There are many examples, and there may be times that there's an exception to the rule, but this kind of shows you an idea of what that looks like. So then a couple questions. What can you conclude about the set of irrational numbers? Well, we have a lot of information based from our notes, and our notes tell us that irrational numbers are not closed under any operation. And so this kind of shows several examples of that. So irrational numbers are not closed under any operation. Okay, then the question says, what can you conclude about division and the closure property for rational numbers, irrational numbers, and integers? Well, it appears that that none of them are closed under division. Okay, so then start thinking about our division with rational numbers. So besides 0, is there another number that makes it not closed? So if I took 1/2 and divided it by 2/4, or if I took 1/2 and divided it by 1/3, I'm still going to get a rational number any other time. So no, there's not another example that I can think of. I can think about as many rational numbers as I can, and I'm going to, when I divide them, get a rational number. So it seems like it is closed under division, just with the exception of division by 0. And we have that in our notes already. If you look back in our notes, it does say that, let's see, rational numbers are closed under all operations with the exception of division by 0. So rational numbers are closed under division with the exception of division by 0. And that's just kind of an exception to a lot of different rules. When we start talking about dividing something by 0, it tends to change a lot of things. So hopefully this kind of exploration just kind of helps you see a little bit more clearly how the closure property works, and kind of how things can have one exception, or kind of maybe show you a few more examples of what these closure property type questions look like.